Okay, in this video we're going to take a look at the different types of formulas for the definition of a derivative. So let's go ahead and start. Learning goal. Students will be able to know what the definition of a derivative is and how to use it. So in earlier videos I showed you how to prove one of them, but I really didn't show you the other types of formulas. So we only did one proof, not the three. Let's review what a derivative is. A derivative simply is the slope of a tangent line to a curve at some point. Alright, and so today we're going to take more of an analytic approach. Remember, there's three different ways to actually solving a limit. The first one is numerical, the second one is graphical, and we're going to take a look at the analytical. Alright, so the one that we proved, the big kahuna, we proved that the definition of derivative is basically the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. And that will give us the first derivative, and we're going to see how to actually use it. There's also two other forms. Now, the first one is the same as the delta x one, and the only difference is that I have h's. So when they proved it, they just said that the small change was called h. No biggie. You just put it in a x plus h, or into the function instead of x plus delta x. The second one is also a definition of a derivative, and it's not as common. It's more for like radicals and stuff like that. Anyways, it looks like this: limit as x approaches c of f of x minus f of c all over x minus c. Very easy. We'll take a look at it today. And then the third type looks like this: limit as h approaches 0 of f of a plus h minus f of a minus h, hard to say, all over 2h. The most common one is the first one. That's the one that you're probably going to be able to use all the time, but it's good to know the other two just in case they require it of you. Okay, so example 1, my favorite function, x squared. So I'm going to use the just traditional definition. Let's go ahead and begin. So basically I'm going to write the limit as h approaches 0. Now this is just a formula. This tells us what to do. This says everywhere in my function that I have an x, replace it with an x plus h. So let me go ahead and do that. That would be x plus h squared. And then this says everywhere I see an x in my equation, put in an x. Okay, that's easy. That just makes x squared all over h. Now the trick here is this: if I plug in a 0, I'll get 0 over 0, which is indeterminate. I need to simplify the top so I can get rid of the denominator and then evaluate the limit. So I'll say it again. I need to simplify the top so I can hopefully get rid of the denominator and then evaluate the limit. So let's go ahead and do it. So limit as h approaches 0. Now it's important that you don't drop this part. Even though we get lazy, we want to rewrite the limit as h approaches 0 till we evaluate the limit. And if I expand this, if I FOIL it or distribute, I get x squared plus 2xh plus h squared. And then I'm just going to rewrite the minus x squared all over h. Alright, we're in great shape. Let me grab my Mr. Red for some canceling. Okay, x squared and negative x squared can be canceled out. Now, notice that in my numerator, I have multiples of h. That's great. That means I can cancel out the denominator. So limit as h approaches 0 of 2xh plus h squared all over h. Now what I'm going to do is I'm going to factor out an h out of the top. So limit as h approaches 0 of h times 2x plus h all over h. I'm going to grab Mr. Blue again. I can cancel the h's out. So now I don't have to worry about my denominator being 0. Evaluate the h and you get 2x. So the first derivative of y equals x squared is 2x. Great. And how you would write that for a reader is y prime is equal to 2x. Alright, that was our first derivative. I'm proud of you guys. Okay, example 2. We're going to use the second definition of a derivative here. Same function, so you guessed it, we'll probably get 2x hopefully for our answer. So let me go ahead and start. We get limit as x approaches c, And then it says here, everywhere I see an x, put in an x. Okay, that's easy. That just makes x squared. Then everywhere I see an x, I put a c. So minus c squared all over x minus c. Okay, that's the formula. It's looking great. If I put in a c right now, I'll get 0 over 0. So I want to do some factoring. So limit as x approaches c. We're going to factor the top. It's a difference of squares all over x minus c. And then remember, what we do is we simplify or factor the top so we can cancel out the denominator, which those are gone. And so I simply have now limit as x approaches c of x plus c. Okay, evaluate the x. So if I plug in a c for x, I get c plus c. Notice I dropped the limit, okay, because I plugged in. So that makes 2c. Well, 2c in this case is the same as x. C and x are interchangeable for the x-axis. So yes, the answer would be 2x. The first derivative is dy over dx is equal to 2x. I'm just flip-flopping my notation, which is the same as y prime. Alright, not too bad. Okay, let's take a look at the third case here. Let me grab a different color here, green. Okay, so this one's a little bit more work. That's why we don't use it as much. But let's give it a try. Limit as h approaches 0. Everywhere I see an x, I'm going to put a plus h. So this is going to be a plus h squared into the function. Minus, and I'm going to put a grouping symbol here. Everywhere I see an x in the function, I'm going to put a minus h. So a minus h all squared all over 2h. I know this looks scary and looks like a mess, but don't worry. I'll guide you through it. Okay, so I got to write a little smaller here. Limit as h approaches 0. Now I got to expand it, because if I put in a 0, I'll end up getting 0 over 0. So if I expand the first term, I get a squared plus 2ah plus h squared. Okay, we're doing great. Minus, and then if I expand this one, I get a squared minus 2ah plus h squared all over 2h. I know it looks like a big mess, but trust me, it won't be too bad. Okay, let me grab another color to switch it up a little bit. If I distribute the negative here, I end up getting negative a squared plus 2ah minus h squared. Now I can cancel some stuff out. The a squareds are gone. We can also cancel out the h squareds. And so if I rewrite this, I get limit as h approaches 0 of 2ah plus 2ah all over 2h. Okay, let's see if we can simplify here. I can factor out a 2h out of both terms on the top. So limit as h approaches 0. Well, you know what? To make it even easier, can't I just combine them? That's just 4ah over 2h. If I cancel out the h's and cancel this, I end up getting nothing to evaluate for h, so it just gets 2a. Now, x and a can be interchangeable, so the first derivative is 2x. So y prime is equal to 2x. Alright, I know that was a mouthful. Let's go back up to our learning goal. Let's see if we hit it. Students will be able to know what the definition of a derivative is and how to use it. I would say practice a little bit more. It's a lot of fun, and I'll see you on the next video.